Hello guys, welcome to RAMSAI IAS. In this video, I am going to explain you how to solve syllogism problems. Many people feel that syllogism is a very difficult topic. But when you know the basic concept, solving syllogism problems is a cakewalk for you. So let me explain the introduction. Okay, we can solve syllogism in two different ways, but in this video I am going to explain you only one method, that is by using logical Venn diagrams. Here there will be, in syllogisms normally I'll show you an example. The question will be like this. It will be two statements followed by two conclusions. Okay, now we need to check whether these conclusions are following the statements or not. That's it. Okay, now just by looking at the conclusion and statement, we cannot determine or we cannot decide whether conclusions are following statements or not, because just read the statement, all greens are blue. How can all greens will be blue? Not possible, no? And all blues are whites. How it could be possible? And in few questions there will be like all human are boys. How it can be? There will be some girls as well, right? And in some cases all bulbs are fans and some fans are tables. There is no relation between table and fan actually, right? So the main and foremost point is we should never try to understand the meaning of the question here. Okay, and just to solve the problem, we cannot decide whether conclusions are following statements by looking at the problem. No, then how? We need to draw logical Venn diagrams for the conclusions. Okay, and after that, from the logical Venn diagrams we have to conclude, we have to decide whether conclusions are following them or not. Okay, so statement to logical Venn diagrams to conclusions. Then how many types of logical Venn diagrams will be there? I'll explain those, then you will get clear understanding of the concept. Okay, there are total 3 types of logical Venn diagrams we have in these syllogisms. The first model, one circle completely lies inside of another circle. See, one circle completely lies inside of the another circle. Just imagine the outer circle is A, the inner circle is B. Okay, from this diagram I can conclude 3 points. First conclusion, all B's are A's. All B's are A's, right? If you want, you can cross check. Wherever I put a dot inside B, it will be inside of A as well. Yes or no? I'll put a dot here inside B, and obviously this dot will be inside A as well. Now second conclusion is some A's are B's, and third one is some A's are not B's. Yes, some A's are B's and some A's are not B's. Yes or no? See, if I put a dot here inside A, yes, it will be inside B as well. And if I put a dot inside A, it may not be inside B, right? So all B's are A's, but all B's need not to be A's. So if you have any confusion, I'll do one thing. I'll replace the names A and B with animal. B stands for, okay, I'll replace this B with tiger. Now just read the same statements by replacing A with animal, B with tiger. All tigers are animals. Yes or no? All tigers are animals only, and no tiger is a bird, obviously. And some animals are tigers and some animals are not tigers. Yes, of course, some animals are tigers and some animals may be cats, rats, elephants and all, right? So all tigers are animals only, but all animals need not to be tigers. So these 3 are the conclusions I can draw from this diagram. Hope it is clear, right? Now if you want, you can take a screenshot of this. So this is case 1. And in the second case, the relation between 2 diagrams will be like some relation. This is A and this is B. Now I can draw 4 conclusions from this. 4 conclusions. Some A's are B's, some A's are not B's. Similarly, some B's are A's, but some B's are not A's. So some A's are B's, some A's are not B's. Similarly, some B's are A's, some B's are not A's. Hope it is clear. Some A's are B's, so these A's are B's. Some A's are not B's, these are not B's. Similarly, some B's are A's, of course, and some B's are not A's. If you want, you can consider one example like, replace A with A with tall person and B with boy. You see, some tall people are boys, some tall people are not boys. Similarly, some boys are tall, some boys are not tall. Hope it is clear, right? And the third case, so this is case 2. And in the third case, the relation between two circles will be, there will be no relation actually. So third case, case 3, there is no relation between the given two circles. Wherever I put a dot inside A, it will not be inside B for sure. Similarly, if I put a dot inside B, the dot will not be inside A, right? So I can conclude 2 points from this. No A's are B's and no B's are A's. So if you want, you can consider one example like B, replace B with boy, replace A with girl. So no boy is a girl and no girl is a boy, right? Now, if you want, you can put one more circle to represent transgenders. So no transgender is a boy, no boy is a transgender. Similarly, girls and boys also there is, girl and transgender also there is no relation, right? So this is a third case. Just by reading the statements, you have to form the logical diagram. Okay, but remember, there will be two statements in a question. There will be two statements in a question, and in the two statements, one circle will be in common. So we need to draw 2-3 different cases in single diagram itself. Then it will be a bit difficult until you practice few questions. Okay, and later after drawing the logical diagram by using the given 2 or 3 statements, we have to check whether conclusions are following them or not. But remember, very, very, very important point, if you know the relation between the given objects are, these ABCDs, in our terms they are circles. Until you know the complete clear cut relation between them, you should not pre-assume anything. Okay, so if you know the exact relation, then only we have to represent. If you don't know the exact relation between the two given circles, then you should not pre-assume. Okay, so let me start with an example. Here we have total 2 conclusions with 2 statements with 4 conclusions. And now the statements are all green are blue and all blue are white. So let me draw the diagram. All green are blue, all green are blue. So from this I can say all green are blue means some blues are green and some blues are not green, right? Okay, next, all blues are white. See, I cannot represent it with white color, so I'll draw a black circle. See, all blues are white, all blues are white, right? So all blues are white means some whites are blue, some white are not blue. Similarly, already all greens are inside blue, no? Tell me the relation between white and this green, right? All greens will be obviously white only, but all white need not to be green. See, for example, we have a village. In that village, all people are educated. Okay, and normally, I'm not talking about that particular village, but normally all educated people are good, they have good behavior. Then tell me, here village people are green and educated is blue and black is, this white color one is good behavior people. Now all good behavior people need not to be from the same village, but all village people are good behavior because they are educated. right? Now with the similar case, let me check whether conclusions are following the given diagram or not, the constructed diagram or not. Some blues are green, some blues are green. Yes, some blues are green, no doubt in that. Some blues are green. When all greens are blue, some blue must be green only, no doubt in that. That is from case 1. Some whites are green, some whites are green. Yes, all greens are white, but some whites are green. 2 also follows. Now, some green are not white. How it can be possible? All the greens are inside of white only, na? Then some greens are not white. How it will be possible? 3 is wrong. All white are blue. See, all blue are white, but all white need not to be blue. All tigers are animals, but all animals need not to be tigers, right? So 4 are so not following. So here out of 4 conclusions, only 1 and 2 are following. So I will go with option C, only 1 and 2. Hope it is clear. And the next question. All numbers are divisible by 2 and all numbers are divisible by 3. If these 2 are true, then out of these 2 conclusions, how many are true? See, this question was asked in 2020 CSAT, but for this question, you need not to draw any diagram, boss, because this depends on quantitative part as well. No, it depends on numbers and divisibility rules. See, all numbers are divisible by 2 in the sense, see, all numbers are divisible by 2 means the set of these numbers must be even set, right? And all numbers are divisible by 3. All numbers are divisible by 3 means the numbers can be even or odd, because the set will be like 3, 6, 9, 12, etc. Right? Now, if these 2 are true, I can say one thing. If all numbers are divisible by 2 and 3, then the numbers must be divisible by their LCM. What is LCM of 2 and 3? 6. So, if these 2 are true, together they are true, then the set must be divisible by 6, but not with any other number. Let me check with the conclusions. All numbers are divisible by 6. Yes, I told you the same. All numbers are divisible by 4. Not guaranteed, because by satisfying these 2 conditions, we may have the number set like 6, 12, 18, right? Here 6 is divisible by 2 and 6 is divisible by 3, but it is not divisible by 4. Here 18 is divisible by 2, 18 is divisible by 3, and of course 8 is divisible by 6 as well, but not by 4. So I will go with only conclusion 1 follows. So option A, only conclusion 1 is right answer. So the next question. No, this previous one. This question is a bit different from the others, but with a bit of knowledge on LCM, HCF and number system, you can solve this problem easily. Now, the next one. The question which was asked in 2020 CSAT. All cats are dogs and all cats are black. Okay, let me draw different possible diagrams here. All cats are dogs. All cats are dogs. Similarly, all cats are black. All cats are black in the sense, see, the black can be like this, all cats are blacks, or else the possibility will be like, see, these are dogs and these are cats. All cats are dogs, all cats are blacks, right? So it can be like this as well. The 2 are possible. In fact, you can consider one more diagram like cat, dog, black. So here the statements was based on cat-dog relation and cat-black. Do you know what is the relation between dog and black? No, we don't know directly, but we have in common, the cats as in common, right? And as we don't know the direct relation between dog and black, the relation between dog and black can be like this or like this. It can be like this as well. Okay, but I am not going to consider this one because all the conditions were already cleared in the above diagrams, right? Okay, chalo. Now, conclusion 1. Some dogs are not blacks. Some Okay, conclusion 1. All dogs are not black. All dogs are not black. See, in this case it is okay, but in this case it is not okay, because in second diagram all dogs are blacks only, na? But here all dogs are not blacks, only few dogs are blacks. As we cannot give any guarantee, I am eliminating first conclusion. See, I told you already, until you know the exact relation, you cannot conclude it. Okay, so in the two different cases, the scenario is different. In the second case, yes, all dogs are blacks, but in the first scenario, all dogs are not blacks. So, as there is no guarantee, I am eliminating conclusion 1. Similarly, conclusion 2. Some dogs are not black. Some dogs are not black. See, in the first case, yes, some dogs are not blacks. Now, this highlighted part, dogs are not black. But here, all dogs are black. Here, scenario is wrong. And in the two different scenarios, we are getting two controversial outputs. So, I am eliminating conclusion 2 as well. So, answer will be conclusion 1, conclusion 2. Both are not following. So, I will go with option C. Neither conclusion 1 nor conclusion 2 follows the statements. Right? Next question. Some tablets are TVs and some TVs are radios. Then we have total 4 conclusions. So, but before solving the question, before checking whether conclusions are following the statements or not, let me draw the diagram based on the given statement. Some tables are TVs. Some tables are TVs. Next. Some TVs are radios. Some TVs are radios. Now, do you know the direct relation between TV and radio? No, we don't know. Sorry, a small mistake from my side. Do you know the direct relation between table and radio? No, I don't know, but we have TV in common, right? So, as we don't know the relation between table and radio, we have to check for the different possibilities here. Okay, can I reconstruct the diagram? Some tables are TVs, perfect. And some TVs are radios, some TVs are radios, and you don't know what is the relation between TV and radio, tablet and radio. So, there is a possibility that radio can be like this as well. If you want, you can cross check. Some tablets are TVs and some TVs are radios, perfect. But I don't know what is the relation between tablet and radio. So, the arrangement can be like this or can be like this. It can be like this as well. Now, let me go with the conclusions. Some tablets are radios. Some tablets are radios. See, some tablets are radios. Yes, it is in this case, but no, it is not in this case. As there is no guarantee, I will eliminate conclusion 1. Some radios are tablets. See, some tablets are radios is not possible. Then how it can be the reverse? No. All radios are TVs. No. Some TVs are radios, but all radios cannot be TVs. Similarly, all TVs are tablets. All TVs are tablets. No, only some case. Na? It was clear. Some tablets are, I'm so sorry, yaar. This is not tablet, it is table. Let it be anything. So, it is some tables are TVs. Then how it can be all TVs are tables? Not possible, na? So, this is also not possible. So, correct answer is none of the 4. 1, 2, 3, 4. All the 4 options are not following. So, I will go with none of the 4. Okay. Here, what is the key? We have to consider all the different conditions, all the different cases. Just imagine, for example, if you don't consider this case, okay, then if you draw the diagram like this only, then you may go with option then you may go with option, no, here we don't have option luckily, but just imagine, what if you have another option, only 1 and 2, then you will go with the option F, no? But you have to consider all the different possibilities if you don't know the exact relation. Okay, fine. Next one. Consider the following statements. Of course, here we have 2 statements followed by 2 conclusions. Some men are great, some men are wise. Conclusions are men are either great or wise. Some men are neither great nor wise. Now, very, very interesting question here, and I'll go with two colors here. Some men are great. So, this is men and this is, wait, this is men, this is great. Okay. Second statement, some men are wise. Some men are wise. Okay. And here the possibility. Do you know what is the exact relation between wise and great? No. But we have men in common, na? So the possibility, another possibility can be like this as well. Yes or no? There is any other possibility? No. These two are the possible cases. Let me check the conclusions. Men are either great or wise. So if men are great, they are not wise. If they are not wise, no, then only they will be great. This one is not so exact one, because I can draw the diagram like this. This is men. This is men. Wait. With second diagram itself, we can understand, no? Here we have some common point between them. Wise and great. We have common area, na? So it represents men can be both wise and great. But it is saying men are either great or wise. If they are wise, they cannot be great. If they are great, they cannot be wise. So I'll eliminate conclusion 1, because there can be a common part between great and wise. Okay. Some men are neither great nor wise. Guys, here we have possibility but not guarantee. See, in the above diagram, if you observe clearly, some men are neither great nor wise. Yes, possibility is there, but not guarantee, because I can draw the same diagram like this. It represents wise, blue represents men, and green represents. So nowhere you can see a man without either wise or greatness, right? So I'll eliminate conclusion 2 as well. So ultimately my answer will be neither of the two conclusions are valid. No, they are not following the given statements. Hope it is clear. And the next one. See, 2 statements followed by 4 conclusions. All the books are pencils and no pencil is eraser. Okay. Guys, you try to draw diagram along with me now. All books are pencils. All books are pencils. Similarly, no pencil is an eraser. No pencil is an eraser. No pencil is an eraser. Is there any other combination? No, yeah, that's it. So now, our conclusions are like all the pencils are books. See, all books are pencils, but all pencils need not to be books from case 1, right? So eliminate first one. Some erasers are books. Some erasers are books. There is no guarantee. No possibility actually. If no pencil is an eraser, how can be few books are erasers? No, not possible. And next one is the same. No book is an eraser. Yes, no book can be eraser and no eraser can be book. So I'll go with option, the third conclusion follows for sure. And some books are erasers. Some books are erasers, not possible here. There will be no relation between eraser and book, because if you want to combine books and erasers, we have a forbidden between them, that is pencil, because no pencil is an eraser and all books are inside pencil only. So this also cannot be possible. Now only third conclusion is following statements. I'll go with option A, only 3, right? The next one. Some apples are bats and no bats are cats. Some apples are bats and no bat is a cat. No bat is a cat, right? Is there any other possible diagram, possible outcome? Yes. some apples are bats and no bat is a cat, then cat can have relation with apple, no? So cat can be like this, yes or no? It is a possibility, yes or no? Right. See, here we don't know what is the exact relation between apple and cat, but we have bat in common. So with that, I tried the all different possible outcomes. Of course, you can draw a diagram like this as well. Apple, bat and cat can be inside of apples only without touching bat, or else it can be how it can be possible, and it can be, right, these three are the possibilities actually, right? Now let me check with the conclusions. Some apples are cats, some apples are cats, some apples are cats, no relation, no, this is wrong, right? Right. Next, no apples are cats, no apples are cats, yes, there is no relation between apple and cat, fine. But if you observe, if you check these two conclusions with second diagram, second possibility, some apples are cats, yes, of course, some apples are cats, and no apples are cats, no, this is wrong. Guys, if you observe clearly the two different possible outcomes, if first one is right, second one is wrong. If second one is right, first one is wrong. If you want, you can try with the third one as well. The inner one is cat, this is apple, this is bat. Okay, what is conclusion one? Some apples are cats, yes, some apples are cats only, and no apples are cats. How can it be possible? This is wrong. So it is very much clear. If first one is right, second one is wrong. If second one is right, first one is wrong. So I'll go with answer either 1 or 2. If 1 is right, 2 is wrong. If 2 is right, 1 is wrong. Alright. So either 1 or 2. Now I'll tell you one golden rule here. Whenever in conclusions, right, in conclusions, whenever you see statements like some A's are B's and no A's are B's, let me write it here. Some A's are B's, no A's are B's. In this case, remember, and here the only condition is, in the statements you should not know the exact relation between A and B here. Okay, A and B, sometimes it can be no B's or A's, both are okay. See, it can be AB or it can be AB BA, but there should be no C. See, if the fight is between husband and wife, it can be in the second conclusion also, it can be the relation between husband and wife, or it can be between wife and husband, but girlfriend should not enter. Okay, C should not be there. The relation between A and B in first conclusion should be in the second as well. The positions of AB may changes, but this is very, very, very important. Some no, some no. In this case, blindly you can put answer as either 1 or 2, either 1 or 2. Hope it is clear. With this, next problem. All the locks are keys, all the keys are bats. Some watches are bats. Let me draw the diagram first. All the locks are keys, all locks are keys, and all the keys are bats. All the keys are bats. Next, some watches are bats. Some watches are bats means, some watches are bats means watch can be like this, watch can be like this, watch can be like this as well, right? These are the three different possible outcomes. Now let me check with the conclusions. Some bats are locks. Some bats are locks. Yes. If you look at the red color and green color, this is lock, this is bat. All locks are bats and some bats are locks. Yes, of course, one follows. Some watches are keys. Some watches are keys. There is no guarantee. You see, some watches are bats for sure, but there is no guarantee that there should be relation between lock and watch. Possibility is there but not guaranteed, so I'll eliminate this one. Next, all the keys are locks. All the keys are locks. How it can be possible? All locks are keys, but all keys need not to be locks, right? All A's are B's, but all B's need not to be A's. All tigers are animals, but all animals need not to be tigers, right? So I'll eliminate third conclusion as well. So ultimate answer will be only one. I'll go with option B. Hope it is clear. And the next one. Some keys are staplers, some staplers are sticks, all the some keys are staplers, some staplers are stickers, all the stickers are pens. Let me draw the diagram. Some keys are staplers, some keys are staplers. Next, some staplers are stickers, and all the stickers are pens. All the stickers are pens. See, here you will have multiple outcomes here, because the last pens can be like this, having some relation with keys, and the stickers also may have some relation with keys. So there will be multiple diagrams, multiple outcomes for this. But if you look at the conclusions, clearly. Some pens are staplers and some pens are staplers, some pens are staplers. Yes, it must be, obviously, when it is covering, when all pens are covering stickers, it must cover at least few of staplers. So first one will follows. Second one, some stickers are keys. Possibility is there but not guaranteed, right? There is no relation. Possibility is there but not guaranteed. Eliminate second one. No sticker is a key. No sticker is a key. No sticker is a key. Okay. Sticker, key. Fine. Put it in hold. Put it in hold. Some staplers are keys. Some staplers are keys. Yes. This is also following. This is also following. So now I can conclude 1 and 4 follows for sure. But if you observe clearly, here we have relation between stickers and keys, and the relation is some no. So what I told you, whenever you see relation between the same things with some no case, it will be either or, either 2 or 3, either 2 or 3. So I'll go with option D. Only 1 and 4 follows for sure. 1 and 4 follows for sure, and either 2 or 3. So perfect. The next one. So this question, even without drawing diagram, I can solve the problem directly. Yeah, what is your answer? What is your answer? Right. Some browns are papers, no browns are papers. Brown, paper with some no. So either 1 or 2. Similarly, wait. Similarly, look at this one. Calendar, bag, some no case. So either 3 or 4 also a possible outcome. So ultimately I can go with answer D, either 1 or 2 and either 3 or 4 follows. So with the golden rule I explained you 5 minutes back, we can solve this question and previous question and the previous question as well directly without drawing diagrams. Next one. So here we have final question in this video. Examine the following statements, and we have 4 statements. Given that statement 4 is true, statement 4 is true, this is true, then what can be definitely concluded? Which of the following can be definitely declared, can be concluded? Let me draw the diagram by using the 4th one, as it is true statement. Some colors are not pleasant. So some colors are not pleasant. Color pleasant. Can I draw diagram like this? Right? And where you observed some case in first one also, when P is inside of C, all pleasant can be colors, but all colors need not to be pleasant. In that case, some colors are pleasant, some colors are not pleasant, right? So these two are the possible diagrams. There is no other possibility, right? Now let me cross check with the given statements. First statement, all conclusions are pleasant. All colors are pleasant. See, there is a possibility that all pleasant are colors, but all colors need not to be pleasant. So this is false, no doubt in that. Next one, some colors are pleasant. Some colors are pleasant. Even here also some colors are pleasant. Yes, this is true. This is true. And so I'll do one thing. This is wrong. This is right. Next, no color is pleasant. How it can be possible here? Some colors are, no colors are pleasant. How can it be possible? This is obviously wrong. This is false. Because when 2 is right, 2 will be wrong obviously. Yes or no? So this is true. Sorry, first one is false, second one is true, third one is false. Now let me go with options. 1 and 2 are true. 1 and 2 are true. No, only 2 is true. First one is false. So eliminate this one. Option B, 3 is true. 3 is true. No, it is false. So eliminate this one. Next, 2 is false. How it can be false? It is true actually. So eliminate this one. And 1 is false. Yes, 1 is false. So this is the only correct option we have from the statements.